Okay, we're up and running. Okay. The car has to travel a distance s on a straight road. The car has a maximum acceleration a and a maximum deceleration b. It starts and ends at rest. Show that if there is no speed limit of phi ms, the time taken to complete the journey is given by phi over 2a plus phi over 2b plus s over v. Okay, so what you're going to have to do here. Okay, so what you're going to have to do here is the following. Okay, you just underline your keywords, okay, as your key information as you go through. You're going to have S here, maximum acceleration A, deceleration B, starts and ends at rest. These are your keywords. Show that if there is a speed limit, so we know there's a speed limit of V. If they put a speed limit in it, what do we know about the diagram? The shape of the diagram? Triangle, rectangle, triangle. Okay, so we're just going to put some structure onto this now. Okay, now we're going to have three areas. We're going to have area A, B, and C. Area A, area B, area C. We know that it's capped at V, a height of V. Okay, and we have to go about finding our times. Okay, yeah. So what we can do here, if we know this is V, and we know the acceleration is A, we're going to use phi equals u plus at for both of them. Okay, so u plus at. Okay, so for the first section, which is the acceleration section, okay, phi equals u plus at. Phi is v, u is 0, acceleration is a, so it's at. So we'll call this t1, okay? So at1. T1 ends up to be v over a, which is grand, right? So we know that first time t1 is phi over a, and we're going to work out what we'll call this t2 here. Okay, so we're going to work out what t2 is. We're going to do the exact same procedure. Phi equals u plus at, and then we're going to do here, we're going to say v is 0 in this case because you end up at 0. U is going to be v, and at1, it's a deceleration, isn't it? So deceleration is going to be minus bt2, deceleration of b. And then when you work that out, you're going to get bt2 equals v, t2 equals phi over b. Is that right with us? Okay. Now we're at the stage where we can just create the diagram that's obviously in the solutions. Okay. So I'm going to redraw this diagram in blue here, and all of a sudden we're going to have something that looks like this. Obviously a bit bigger this time. Okay, so now we know that T1 is phi over A, T2 is phi over B, and the height of each one is V. Okay, and then we have a time segment in the middle we don't know about. So what we can work out is distance A and C. Okay, so distance A and C, if you look at your notes there, distance A and C can be worked out. I'll work this out in red here. Okay, so distance A is equal to the area of a triangle. It's a half base by height, so it's going to be a half phi over A multiplied by phi, which is going to get us phi squared over 2a. The next one here is going to be distance C, and what that's going to be is a half phi over B times V, which is going to be phi squared over 2b. Now, what we're also asked here is basically, we're asked the total distance is what? Total distance adds up to S, doesn't it? Yeah? So distance A plus B plus C equals S. This means the distance B, and if we revert back to the question here for a second, time taken to complete the journey. Okay, so we actually need to find out the distance or the time taken in the middle to find the time taken in the journey, don't we? Okay, so to find the whole goal of this question is you have to find the distance at constant velocity, and once you get the distance at constant velocity, you can get the time at constant velocity. Okay, because you know it goes v all the way across. Okay, so just to reiterate that point, we're going to find out the distance b, then we're going to divide it by the speed because it's at constant velocity all the way through this section. Okay, so what we're going to get then is that's all equal to s. And then what we're going to know about this is that distance b is equal to s minus a minus b. Then we just put it all in, and we're going to get s minus phi squared over 2a minus phi squared over 2b. Okay, and then also what we gotta do now is we gotta find the we have to divide this by. So time for constant velocity, time equals distance over speed, or distance over velocity. So this here is the distance b. I'm going to divide it by this velocity, which is v, and when I do this I'm going to get s over v minus v over 2a, because v will cancel with v, minus v over 2b. And that's basically time, let's call it t3. Okay, and t3 is being the central time. Okay, now all I gotta do now is add them all together. Okay, so total time equals t1 plus t2 plus t3, which is going to give me t1 is phi squared over 2a, t2 is phi squared over 2b, t3 is going to be s over v minus phi over 2a minus v over 2b. Okay. Oh, excuse me. It's not phi squared over 2a. That was actually the distance. Phi over a was the time we worked out. Okay. So phi over b. So I just just visit that point again. The distance was phi squared over 2a. The time was actually phi over a, and the time for that section was phi over b. Okay, so please double check your work before you begin any major calculations. Okay, so what we're going to have here now is you're going to realize if you just go with a different colored pen here, you realize the two of them are very similar. You realize the two of these are very similar. This one here is basically a half phi over a, and this one here is a half phi over b. So phi over a minus a half phi over a gets you a half phi over a, doesn't it? Or basically phi over 2a. The next one's going to be plus phi over 2b. And the next one is going to be plus s over v. And that's what we're asked to prove, wasn't it? Yeah. So Q, E, D. This is what you're asked to prove. It's Latin for quod erat demonstratum, which means you proved what you're asked to do. Okay. Can I move on, or does anyone want to take down the rest of that? Or okay. For this question here, we know that there's no speed limit, so what's going to happen is it's going to go all the way up, and then it's going to hit a maximum speed limit. It's not even going to hit maximum speed, but we know that it has to end at rest. So there will come a point where he has to say, well, if I want to get to rest within the distance, I'm actually going to have to jam on the brakes and get my velocity all the way back down to zero where it began. Okay, we once again are capping the velocity. Show that a speed limit of v. So in this case there is no speed limit, okay? But we're still going to have to call it something. So remember, the v I used in this question is completely different from the v I used in part 1, okay? So once again I'm going to cap this and call this v. Okay, and I'm going to break it up into two time slots, t1 and t2. And we know that the acceleration A and B, okay, so the acceleration is A and the deceleration is B. And that's all the information I can have for this information at the moment, okay. So what we're going to do next is we'll just start trying to work out some times, okay. Now, there's a ratio here, isn't there? What do we say about the ratio of acceleration to deceleration? So, the ratio of acceleration, that's meant to be two dots. Okay, the ratio of acceleration to deceleration is the same as the ratio of t2 to t1. Okay, just going to pause it here. Now, t2 to t1, okay, so what we know is that the ratio of t2 to t1 is the same as the ratio of acceleration to deceleration, okay, so it's going to be acceleration to deceleration is the same, so it's going to be A is to B, okay. So I have T2 to T1 written down. In the solutions, they have T1 to T2 written down, which is going to be B dot dot A. You can just spin them around, it's all the same, okay? Now, the next thing we got to do is you actually got to go about figuring out what actually is T1 and what is T2, okay? So, we'll just quickly rub this out. Okay, let's go for, you've asked our system for acceleration. Just starting off with acceleration. U is 0, V is V, that's A, and this here is going to be T1. Okay, so use V equals U plus AT, yeah? So V ends up to be AT1, doesn't it? V turns out to be AT1, and V equals AT1. Now, I think I'm missing a trick here. Just give me a second. Usually when you're dealing with ratios, okay, you're actually dealing with fractions. Okay? So what fraction is it of the entire thing? Okay? So if you were to have a ratio 5.3, what we always do is we add 5 and 3 together, and what we say is, okay, 5 and 3 is 8. The first section is going to be 5/8, and the next section is going to be 3/8. So for example, B is going to be B divided by A plus B. The exact same technique as last time. You add the two of them together, and then you divide by it. And this one here is going to be A divided by A plus B. Okay. Now that we have the race, now we know what fraction of the entire time. So if you imagine the total time was divided into a ratio of 5 is to 3. The first time would be 5/8 the t, and the second ratio would be 3t. Do you got it? Okay. So what we're going to say in this case is that we're just going to apportion the time now. Okay. So it's going to be b over a plus b to the power of multiplied by the total time, and we're going to let the total time be equal to t. So we're basically apportioning the fractions of the total time. Okay, and the next section is going to be a divided by a plus b divided by t. So that's what t1 and t2 are going to be equal to. Okay, so t1 is going to be this one. As you said earlier, t1 is represented by the b part, and t2 is represented by the a part, and t2 is going to be at plus a over b. Okay, next section is we want to find the area. We know that the area equals S, okay? Always a good point to revisit the question now. The time taken, we're still looking for the total time taken, okay? So, in order to find the time taken, we need to find the distance, the total area in terms of the time, okay? So, what we're going to get here is the area, And as somebody was saying earlier, it's a big triangle this time. So it's going to be a half the base multiplied by the height. Okay? But what do we know about the base in this case? The area is going to be half the base, and that's going to be a half big T times V. Okay? Now the problem with half big T times V is, do we have a big T in our answer? No. Okay, so it means we're going to have to substitute it with what we know already. And what we know already is that big T equals T1 plus T2, isn't it? So what we're going to have to do here is we're going to have to add the two of them together and reduce the fraction. Okay, so T1 plus T2 is, it's going to be, when we add these two together, it's going to be BT over A plus B plus AT over A plus B. And what this is going to get us is B plus A times T all over A plus B. Ah, yes. Now, how do you know you've made a mistake here, lads? Because T equals T. Now, what happens when you make a mistake? What does that mean you've used? You've used the same information set twice. Okay? So my goal was to change big T here into A plus B. So that's failed for me. I've known I've chosen the wrong one. So instead of changing big T to A plus B, I'm actually going to try and change V into it. Okay? So you know you know when you've used your same information set twice, when you get something like 1 equals 1, S equals S, T equals T. It can happen. If it does happen to you in a test, what you need to do is you need to go back to the drawing board and say, wait a minute, I tried for T, now I'm going to try for V. So let's try out for V. So V is equal to U plus A T, yeah? Then you're going to say, okay, fair enough. I'm going to go V. I'm going to use this for the acceleration part, if that's okay with this. So U is 0. A is still A, isn't it? And we said, what did we say T1 is? T1 is B over A plus B, big T. Okay? And then we're now going to know that V equals ABT over A plus B. Okay, now we can rewrite the area. Now we can rewrite the area as follows. A half bracket ABT over A plus B. A half ABT over A plus B, and all that equals S. Okay? So what we want to do is we want to isolate T. The whole point of this question was I want T on its own. So what we're going to have to do here is we're going to have to isolate T. Now it's a half T. I forgot the other T here, didn't I? Yeah? So what we're going to end up with is T squared. And what I'm going to do in order is I'm going to bring the A plus B up here. And I'm going to bring the AB. It's going to go down here. And the half, the number 2, is going to end at the top. So there's just 3 different movements going on. Each arrow represents which movement is going on, okay? So what you're going to end up with here is you're going to end up with T squared ends up to be equal to 2S brackets A plus B. Notice the 2 and A plus B both go to the top. The AB goes to the bottom. And then all you want to do is T equals the square root of all of this, okay? So you're going to square root all of it, and you're just going to make it look like your answer. 2S into A plus B divided by AB. Okay. Very difficult question, lads. Very difficult. Okay. A train accelerates from rest at a speed vms. It continues at this constant speed for a certain time, then decelerates uniformly to a rest. If the average speed for the whole journey is 5v over 6, show that 4/5 of the whole distance is covered at a constant speed. So we want to, what we're asked to do in this question is we're going to draw a velocity time diagram. The giveaway for a velocity time diagram start off is the 3 periods: the acceleration, a flat period, and a deceleration. Okay, that's a giveaway. The next thing you're going to say is, okay, fair enough. I had to prove that this middle section, I had to prove that the rectangle is 4/5 the entire distance, okay? So the 4/5 of the whole distance, not the whole time, the whole distance is covered at a constant speed, okay? We're going to do what we basically did last time, okay? We're just going to divide it up into 3 sections, okay? So what we can call these sections is we're going to apportion 3 times, okay? They're very much the times. So let's apportion 3 times. We usually use T1, T2, and T3. Okay, in this section they're just going to use X, Y, and Z. So I'm just going to remind you that X, Y, and Z are the times. X is T1, Y is T2, and Z is T3. Everybody happy with that? Okay, and we're going to call our velocity cap, or our maximum velocity, V. We always call it V. Okay, next section then. What we're going to do now is we have all the information we need. We're just going to go about using our information. Now, we're given the average velocity in this question, aren't we? Are we given the average speed? So what is the formula for average speed? Average speed is total distance divided by total time. Okay. And what happens here is you basically say, fair enough, total distance divided by total time. Total time is going to be all the letters added together. X plus Y plus Z. Is that okay? Okay, so X plus Y plus Z. The next thing we're going to do is we're going to get the first triangle, okay? The triangle is going to be a half base by height, which is going to be a half Vx, yeah? The next one's going to be what's the area of the rectangle? Remember, the total distance is the triangle plus the rectangle plus the last triangle. So it's going to be Vy. The third triangle? Sorry? A half Vz, okay? So that's where we're at now. Now, we all know that this equals 5v over 6, don't we? Because we're told that at the very start, that the average velocity. So what the section we're going to do is we're going to bring this blue part up here, multiply it by the 5v. We're going to bring the 6 up here, and we're going to multiply 6 by absolutely everything there. Okay? So what we're going to end up with, the blue section is going to look something like this. 5vx plus 5vy plus 5vz. The red section is going to look like 3vx plus 6vy plus 3vz. Now we're going to look at both sides, and what is our purpose here? We want to find out how much bigger y is than x and z. This will give us a reference for our time. If we find out an equation that relates x to y and z only, we can find something out about the time. That's what we're looking to do here. Okay? So what we're going to do is we're just going to bring the 3vx over one side. We're going to bring the 3vz over the other side. And we're going to bring the 5vy over this side. Now the reason why I'm doing this is I want to get y in terms of x and z. So when I bring 6vy minus 5vy, it's going to be 1vy. Do you got it? And then on the other side, we're going to have 5vx minus 3vx is going to be 2vx. And we're also going to have 5vz minus 3vz, which is going to be 2vz. What should we have gotten rid of? Probably right away as well. The v's can go, can't they? And what we're going to be left with is that we're going to be left with y equals y is going to be 2x plus 2z, which can also be written as a half y equals x plus z. Okay. Now, what's basically happening is we're told that the time spent accelerating plus the time spent decelerating is half the time spent at constant velocity. Isn't that correct? Why? Can anybody explain to me why is the distance going to be 4/5 though? So what we gotta do next is we gotta find the fraction of distance. Where the whole point of the question is to find out, show that 4/5 of the whole distance is covered at a constant speed. If 4/5 the whole distance is covered at constant speed, what you want to prove, what you're looking to prove in the first place, is that the distance, you basically want to prove that the rectangle divided by triangle plus rectangle plus triangle is 4/5. You want to prove that your distance traveled at constant velocity divided by the total distance is 4/5. That's the aim. Okay? And so what we can do next is we can just gonna have to get a formula for our entire distance here. So we're gonna try and get the total distance, okay? So we know that the rectangle is y multiplied by vy, isn't it? Yeah. So we know that the rectangle is vy. I'll use a different colored pen here. Vy. We know that this one here is going to be a half xv. We know that the one down the bottom here is going to be yv. And we know that this one here is a half zv. Excuse me. Zv. Now, what we're going to have to do here is that you're going to notice that what comes in front of the x and the z is the same coefficient of a half. So we're going to get vy divided by, I'm going to group it like this, a half v into x plus z, yeah, plus yv. And what I'm going to do next is I'm going to say, okay, what's x plus z again? X plus z is a half y. So I'm going to get this here is going to change to a half y. Okay, it's going to change to a half y. So now we're going to have vy divided by a quarter vy plus vy. Now, what we're going to do here is we're going to cancel all the vy's, okay? So when we cancel the vy's, that will turn to 1, that will turn to 1, that will turn to 1. And what we're going to be left with is 1 divided by a quarter plus 1, which is going to get you 1 divided by 5/4. Put that into your calculator and you're going to get 4/5. Okay? So we just have to prove that the fraction is 4/5, okay?